5 rocks.
Foliated, non-foliated. Oh, hi! Sorry, I'm here at Stone Mountain in Georgia, still trying to identify this rock using my field guide now. So today you have an activity based off of the rock processes. The rock processes are basically how a rock transforms into another. This is really important because it's going to transition us very smoothly into the rock cycle. Now, you have a lot of information to take in today, and your activity is going to be more assessment based, okay? So I just want you to take your time, do your best, pause the video, and rewind the video as you need. While you work, I'll be here at Stone Mountain continuing to try to identify this rock. What are you doing? Get to work.
The processes. How does one type of rock change into another? Now that we have identified the 3 rock groups, it is time to explore the geologic processes by which they are formed and how these processes can change one rock type into another. Cooling and crystallization. What type of rock forms when lava cools at Earth's surface? As you may recall, igneous rocks form when molten rock cools and crystallizes. Molten rock, magma, originates below the Earth's surface when temperatures are high enough to melt solid rock. Because magma is less dense than the surrounding rock, it flows upward toward the surface, occasionally breaking through the surface and producing a volcanic eruption. Volcanic eruptions may produce various sized fragments, such as ash, cinders, and volcanic bombs. Along with ejected debris, volcanic eruptions can produce extensive lava flows. When lava solidifies at the surface, it forms extrusive igneous rock. Most magma, though, never reaches the surface. Instead, it crystallizes deep below the surface. Igneous rocks that form at depth are termed intrusive igneous rocks. Intrusive igneous rocks may remain deeply buried unless portions of the crust are uplifted and the overlying rocks are stripped away by erosion to expose them at the surface. Intrusive igneous rocks are exposed in many places, including Yosemite National Park in California, Stone Mountain in Georgia, and Grand Teton National Park in Wyoming. To summarize, igneous rocks form when lava cools quickly at the surface, or when magma crystallizes more slowly at shallow depths, as with this sill. This sill formed in a near-surface environment when magma was injected between sedimentary rock layers. Erosion exposed this structure to our view, or at great depth over a very long time. These rocks formed deep beneath the surface and were later uplifted and exposed by erosional forces. Because magma is less dense or more dense than the surrounding rocks, it works its way toward the surface, occasionally causing a volcanic eruption.
Which of the following are not usually produced by volcanic eruptions? Lava flows, stalactites, ash, or cinders. Igneous rocks that form at the surface of the earth are said to be extrusive, intrusive. Igneous rocks that form from magma that crystallizes beneath the surface are called extrusive, intrusive.
Weathering. What are the different types of weathering? When rocks are exposed at the surface, they will undergo weathering, a process which slowly breaks up the rock both physically and chemically. There are 2 types of weathering processes, mechanical and chemical. Mechanical weathering breaks rocks into smaller and smaller pieces, while chemical weathering weakens the bonds holding the surface of the rocks together. Water plays an important role in both weathering processes. In a cold, moist environment, water can enter cracks in the rock. Freezing water enlarges the cracks, eventually breaking up the rocks. This process, called frost wedging, is an example of mechanical weathering. In mechanical weathering, rock is broken into smaller pieces without changing its composition. On steep rocky slopes, frost wedging may generate large quantities of angular rock fragments that accumulate to produce talus slopes. Here we see a process called dissolution, an example of chemical weathering. Just as sugar readily dissolves in water, so too do the minerals in some rocks. This example shows the mineral halite, NaCl, dissolving in water. Halite crystals consist of sodium and chlorine ions that are attracted to water molecules. The water molecules remove these ions from the halite crystal face, causing the mineral to gradually dissolve. In addition to breaking down the rock, water also plays an important role in transporting rock fragments. Running water, glaciers, waves, as well as groundwater are all erosional agents in the weathering process. Rivers and streams move sediment, the load, downslope in three ways. Dissolved and suspended sediments are carried in the general flow, while the bed load, sand, gravel, and larger rock, is moved by saltation and traction. A glacier picks up and transports a huge volume of debris as it slowly advances across the land. Eventually, these sediments are deposited as the ice melts and the glacier retreats. Even as the front of the glacier retreats, melts, the ice and debris within continue to flow forward. Beach drift occurs as incoming waves carry sand at an angle up the beach, while the water from retreating waves carries it directly down the slope of the beach. Similar movements occur offshore to create longshore currents. The net movement of sand grains by these processes transports large quantities of material along the shore. Groundwater is an important erosional agent. The dissolving action of groundwater slowly removes soluble rock, such as limestone, creating sinkholes in subterranean caverns. Later, groundwater deposited these limestone cave formations, including stalagmites, stalactites, and columns. Mineralized groundwater drips down from the roof of a cave, depositing a ring of calcite and forming a hollow tube known as a soda straw. Additional rings of calcite are continuously deposited by the dripping water, gradually building up to form. Wind also plays an important role in transporting sediment, as is evident in this historical image from the Dust Bowl of the 1930s on the Great Plains of the United States. Whatever the mode of transport, eventually these solid particles and dissolved substances, called sediment, are deposited. Frost wedging is a form of mechanical weathering, chemical weathering.
An accumulation of angular rock fragments at the base of a cliff produced by mechanical weathering processes is called a moraine, talus slope, mudslide, or kettle. To increase the effects of a chemical weathering on a rock, it would be useful to increase or decrease the surface of the rock. Chemical weathering alters chemical structures of a mineral by adding or removing elements, breaking it into smaller pieces, changing the shape of the molecules in the mineral, crushing the molecules in the mineral.